Hi everyone, how's it going? Welcome back to another episode of Blockchain and Beyond. As always, I'm your host Farzan. On today's episode, we're going to be talking about a topic which I studied quite a lot about during my master's thesis. This area is surrounding the BGP protocol, also known as the Border Gateway Protocol, which is one of the fundamental ways our internet is connected. I will admit this area is slightly more technical than some of my other episodes, but I will try my best to make it as simple as possible to make sure that everybody can understand it. So to give some background, the internet is now a fundamental part of our lives. We use it all the time, every day, and now even some devices in our house like our fridge, freezers, or even microwaves are now connected to the internet. And at the time of writing this paper, it was January 2021, so it was in the middle of the whole pandemic and lockdowns in most countries. And some of my research pointed towards that in 2020, 57% of people in London had actually worked from home, and 86% of them had done so due to the pandemic. And that kind of just goes to show that the internet is such a fundamental part of our lives. But there's a part of the internet which we don't really see, and this is the Border Gateway Protocol, or BGP for short. And this protocol enables the routing of data from one place to another. So when you from your home want to visit a website, this protocol will enable you to find the most efficient route automatically to your destination. This technology was initially proposed in 1989 by Lougheed and Rika, and widespread adoption of this protocol began in 1994, and since then it's been a de facto part of networking. The big issue with this protocol happens because it adopts a weak trust model where a system assumes that a neighboring system is also a genuine actor and will adopt any information provided by them, given that it doesn't conflict with their current image of the network. And on a fundamental level, this grants malicious systems the opportunity to hijack the traffic of another system. And this attack is known as BGP prefix hijacking, or just BGP hijacking. And one of the most prominent BGP hijacking attacks was actually in 2017. This is when 3 people from America were attempting a DDoS attack to bring down a server for the game Minecraft, but unbeknownst to them, an error in their code inadvertently caused a BGP hijacking, redirecting internet traffic to the large internet service provider DIN, who also manages internet operations for America. And the impact was quite severe. Most of the eastern states of America could no longer access parts of the internet, or where they could, they faced a slow crawl. And if this was just something a group of college students could do, what could an organized criminal group actually achieve with this? This also ties in very well with my interest in cybersecurity and cyber resilience, as the cost of a cybersecurity breach on average was $3.86 million as of 2020. And additional pressures from the regulations such as GDPR ensure that companies are more responsible regarding data that they store and process, and are faced with large fines if they fail to comply. And overall, BGP hijacking just serves as a significant threat to companies, as it can be difficult to identify when they are being attacked until it's too late. And not to mention, the reliance on the internet means it will be almost impossible to operate daily without having a constant connection to the internet. I should also just make a note here that I have extremely simplified the concept of border gateway protocols and the systems which operate using this protocol. I don't want to get into too many of the gritty details, which will probably be difficult to comprehend without any supporting imagery, and probably won't give too much value to most people listening. And then we have the actual solution. In this case, I looked at a project called RouteChain. Their paper is titled RouteChain Towards Blockchain-Based Secure and Efficient BGP Routing, and was written by Mohammed Saad of University of Central Florida. And RouteChain aims to solve the weak trust model of the Border Gateway Protocol by introducing a system that has security on multiple layers, and it's done in a way that can be incrementally rolled out across the network. And the idea of it being rolled out incrementally across the network is one of the most important parts here. So there are other traditional solutions to the Border Gateway Protocol trust issue. However, they require one, hardware upgrades, and two, they're not really backwards compatible. So they require everyone on the internet to upgrade at the same time, which with the widespread nature of the internet is pretty much impossible. So this solution solves both of those problems by one, not necessarily requiring new hardware, and two, everybody can update their hardware at their own pace rather, and they'll still be able to interact with the internet as a whole. So RouteChain implements a bi-hierarchical blockchain, which means that there's a central blockchain and then smaller blockchains coming off of it, and a modified proof of authority system. The idea behind having one main blockchain and then smaller blockchains coming off of it is an idea called sharding, where the network is split into smaller pieces for mostly speed. However, security can still be maintained if there's enough people operating the system as a whole. So how this solution works is that a bunch of systems are algorithmically grouped together. This is chosen by the protocol. So in my example, I kept it simple and said that 4 systems are grouped together, A, B, C, and D. And then through the proof of authority system, system A is chosen as the operator in this time period, and then B and C are chosen as backup nodes in case A is unavailable. At this point, system A can now propose any changes to its networking table, and this will all be logged on the shared blockchain between these 4 nodes. Once it has proposed any changes it wants to, the proof of authority now moves to the next node. In this case, system B will now have authority and can make any changes to its networking or routing. And in this system, we need more than half of the nodes to act maliciously before the system is compromised. So in a system where there are 5 nodes, half of that is 2.5, so that gets rounded up to 3. So we would need 3 nodes to be acting maliciously or with ill intent to actually impact this network. And once some sort of stable outcome has been determined by a group of nodes and written to their shared blockchain, they can then push it to the global blockchain, which will allow the impact of the global blockchain is that any node which is not part of the group can then use this global blockchain to identify the most efficient routing to this other node. And as part of this RouteChain paper, there's also some other parameters which they discuss. One of these is that the consensus time would be approximately 20 seconds. I discussed that the global latency would not be a problem, so systems on different sides of the globe can be connected together in a way which is not impactful to the efficiency of the overall system. The paper also discusses a few different types of sharding methods. So the first was geographical proximity, where nodes are grouped together based on their closeness to one another. So systems in the US would be connected to other systems in the US, systems in Europe would be connected to other systems in Europe. This comes with the issue that a malicious actor may be able to identify the physical localities of these systems, which they would need to attack to infect several systems within an area. These facilities may be vulnerable to social engineering attacks, which could lead to further danger on the network. On the other hand, by using random sharding, where systems are randomly grouped together, it can create some confusion regarding the identity of these systems, and any malicious users will have difficulty identifying the system or systems which are in charge of a particular group. And that covers most of how the protocol and system actually works. So in terms of the work I did for my master's thesis, I created a script which would randomly generate a network based on some user parameters and allowing the user to pick, for example, a malicious node within this network. And the simulation would run through the steps of how a malicious node may impact the network overall in terms of where traffic is redirected to. I then created simulations to represent what would happen to this network if the RouteChain solution was actually implemented on this network, and even compared the outcomes to where sharding was included and where sharding was not included. And the overall results of this research, or my research rather, showed that where there was no sharding, the network was more secure. However, it required the person carrying out this attack to already have a widespread infection across the network. This comes at the compromise of speed. On my simulation, I calculated that at maximum there was 10 hops which needed to be done, compared to the 4 hops which were required if we implemented a sharding based system. Not to mention that if we had no sharding, the amount of internet traffic would actually increase exponentially, which in the long run, as more devices join the internet, could see entire network slowdowns if technology does not change to match this growing demand. And with that, I think I have covered everything that I wanted to. So just to give a bit of a recap, so BGP, or the Border Gateway Protocol, is a routing algorithm used by most devices on the internet to help get them from point A to B. The problem is that a device will accept any information given by another device, and there's no sort of security checks done. Traditional means to prevent this are unrealistic in today's growing age. So now we're reliant on some sort of blockchain solution which can be incrementally rolled out across the internet. And RouteChain achieves this. It does this by grouping nodes together in a click, and this click uses a proof of authority system where they take turns in writing changes to their local blockchain or ledger. Once some changes have been made, this then gets pushed to the global blockchain where any other device can use this to identify an efficient route. From my research, I found that a no sharding approach was actually more secure, but it comes at the cost of speed and efficiency of the entire network. So I think a sharding approach is definitely the future if this sort of system was to be implemented. And that about wraps it up for today. It was quite nice to revisit one of the topics that I spent about 6 months researching after not seeing it for 6 months. And what I'm probably going to do now is look at more developments in this area and see what new technology is available. I remember seeing some solutions which were implementing smart contracts and token-based systems to be used by internet routers and systems, which is more akin to some of the other technology we're seeing in crypto projects and could potentially be implemented into other blockchains such as Ethereum or Algorand or Helium even. And anyway, yeah, that's all from me. If you have any questions, feel free to give me a shout. You can find me on social media, and it would be great to hear from you. But until next time, yeah, goodbye.